So I'll start off by doing a comparison between our bladder pumps and double valve pumps, so our two pneumatic pump options. Then I'll be looking at deployment options. So in that section, I'll be talking about a portable versus a dedicated setup and all of the components involved in those. Then I'll take all that information and apply it to real world situations. So I put together a few case studies where I'll give you the background of each of those particular applications, and from that determine what's the most suitable, or what I believe is the most suitable option to meet that particular requirement. So on the screen now, you can see all of our different groundwater samplers that we have available. And as you know, today's focus and the next two will be focusing in on the pneumatic pumps. So that's in the center of the image you can see on your screen. But I just wanted to draw your attention to the other sampling devices we have available. So even though I'm focusing on pneumatic pumps, we do offer lots of other options. So if pneumatic pumps are something that might not fit into your needs, then we do have other pieces of equipment available. And you'll see one of the PDF handouts that I've included is our groundwater samplers chart. So that's just a chart form of everything you can see on the screen here. So it has all the sizes, depths they can be used to, tubing examples, all of that. But on the screen here, these are just images of all of those. So we have our peristaltic pumps, discrete interval samplers, inertial pumps, so foot valves, and then we have bailers, so whether those are the stainless steel point source or just the plastic biodegradable BioBailers. And you'll also notice I've included two images of our low pressure packers. You might be wondering why those are there. Well, those work in conjunction with a lot of our equipment, but more specifically in this particular case with our pneumatic pumps. So we do offer a pump to packer adapter for the pumps that I'm talking about today. And that allows you to sample below an isolated zone, is one of the ways you can use the pump to packer adapter. So now on the screen, you can see a typical pneumatic pump setup. So I just want to go over the various components that make a complete setup. And then over the next few slides, I'll get into detail on each one of those components. So a pneumatic pump, what actually makes that pneumatic? It needs to have an air source or a gas source to complete the operation to make it fully functional. So in the center, you can see we have our portable compressor. So you need that gas air source, so either a compressor or a two-stage compressor, or if you're using more pressure, then maybe a compressed cylinder. And obviously we have the pump or the sampling device, which is downhole. We have the electronic control unit that's used to regulate the flow between your gas source and your pump. And then we have the connection point at the surface, which then goes out to your sample bottle. So all of the pieces you can see on the screen there make up a complete pneumatic pump setup. So just keep that in mind, that you need all of those components to have a fully functional system. Now, Solent's pneumatic pumps, I'm going to talk about the two options we have available, but before I do that, I just want to step back a bit and get a thought process going of why you would actually want to use pneumatic pumps for your sampling needs. So one, they're a widely accepted sampling protocol. So a lot of the regulators worldwide call on pneumatic pumps for that type of sampling. So that's why we're focusing in on that, because it is so widely accepted worldwide. Also, if you think about using a bailer or an inertial pump, when you're lowering that down into the well, maybe with an inertial pump, you're moving that up and down, you're creating a lot of turbulence in the well. So depending on the type of sampling you're doing, let's say you're sampling for VOCs, creating all that turbulence could then lead into off-gassing of those VOCs. So when you actually collect your sample, it's not fully representative of the true condition. So with the pneumatic pump, you lower that in place, you start your sampling, there's no moving pieces that affect the well, so you're not creating that turbulence that normally wouldn't be there. And also, if you think of using a submersible pump, you lower that down into the well, you turn the motor on, that motor is a heat source. So you're introducing heat that normally wouldn't be there within the column. So you're just making a condition that isn't naturally occurring. So with a pneumatic pump, there's no mechanical pieces that are down well, so you don't have that external heat source causing variations that normally wouldn't be there. So those are just a few things or reasons why you'd want to deploy or use a pneumatic pump. Obviously, there's a lot more than that, but those are kind of the key three key points of why you might want to use pneumatic pumps. So now jumping into the two options we have available. So we've got our 407 bladder pump and our 408 double valve pump. So on the left-hand side of the screen now, you can see our 407 bladder pump, and on the right-hand side, you can see our double valve pump. Now, what makes these different? So just envision lowering a bladder pump down into the column of water. So as you're lowering that, the bladder is filling up with water, and then water goes up the drive line to static, or up the sample line, sorry, to static. Then during the drive cycle, when you're pushing air from the surface down into the pump body, on the left-hand side, you can see two orange arrows pointing in on the bladder. So what happens there, the bladder compresses, so squeezes together, and when that squeezes, the sample is pushed up the sample line to the surface. Then during your vent cycle, that pressure is released, the bladder fills back up, and then during the drive cycle, it squeezes again. So that fluctuation of squeezing, releasing, is what causes the sample to rise to the surface. Now, a bladder pump is so widely accepted mainly for that reason, because you have one dry side, one wet side. So you can say with 100% certainty that the drive gas has never come in contact with the sample inside the bladder. So you've got defensible data. When you're submitting that for analysis or submitting your results, you can say with 100% certainty the drive gas didn't come in contact. Now on the other side, with the double valve pump, the way that operates, again, just envision lowering the pump body down into the well. The body fills up with water, and water goes up the drive line and the sample line all the way to static. Then during the drive cycle, water is pushed down through the drive line, through the pump body, up the sample line. During the vent cycle, water fills back into the body, goes back up the drive line, and then when you drive again, it pushes down through that U, and that series of falling out, going back, is what pushes your sample up to the surface. Now, I don't want to get into any more detail on that because webinar 2 will get into more of the operation of the two pumps, so we'll explain that further. And in the meantime, if you are interested in learning a bit more about that, we have a couple YouTube videos that show the operating principles behind both pumps. Now, in terms of the different configurations or options we have for each, our bladder pump is offered in two sizes. So our 1.66, which is in front of me here, so it's got a larger diameter on the pump body, which means it has a larger diameter bladder, which has a higher volume. So you've got more volume within the pump body compared to our second option, which is our 1-inch. So it's used for narrower applications, maybe a portable setup. It's more lightweight, so you don't have the larger pump to have the weight. Now, you can use the larger pump in a portable setup as well, but the 1-inch is nice. It's easy to carry, fits into those smaller diameter wells. Then for the double valve pump, we again have the 1.66 inch. So from the outside, it looks the same. The only difference with the double valve, on the inside, we don't have the bladder, and then we have a drop tube assembly instead of that bladder inside. So larger 1.66, and then we also offer the 5/8 inch diameter. So for narrow applications, you can use this guy here. Really lightweight, nice and portable, so it works out well in portable setup, which I'll discuss here shortly. Okay, so now moving into the actual deployment options. I've talked about pneumatic pumps, what they are, why you would use them, and then the options we have available. That's great, but how do we actually then deploy those into the field? So the first option I want to talk about is a portable setup. So this would be if you have all the equipment with you in your truck or your car, you take it out, drop it in the well, do your sampling, pull it all up, take it to your next well, or take it back to the office. So that would be a portable setup. So we start with our sampling device, or our pump, which would be down well, and that would be any of the options I've just discussed. So I won't go into any more detail on that. Next piece, you're looking at your electronic control unit. So I mentioned at the beginning, this is used to regulate the flow between your gas source and the pump, and that's done through everything you can see in front of you here. So we have our pressure regulator, so it's a turn gauge here that with the pressure gauge you can see what you have set. Battery operated, so it runs off of 4 AA batteries. So those are easily obtained at any convenience store, gas station. So if you do need to have replacement batteries, they're easy to find. We have our quick connect fittings over here, so for our drive line and sample line adapters, so you can mate everything together with just your quick connect fittings. LCD screen up here, so that shows the particular settings that you've set for that sampling event. Inside the memory, we've got presets, so low, medium, and high flow settings. And you also have the ability of saving up to 99 user sites. So if you've got some number of wells, you can save the event. So when you show up next month, next year, you just select the name of that particular site, and you can see all of the parameters that were used in your previous sampling event. And then we have our manual override button over here. So that works out well. Let's say your batteries die at the end of the day and you still have some sampling to do. You're able to operate the control unit just by pressing the button to drive, releasing to vent. So if you don't have replacement batteries, you can still use the control unit and do what you need to do. On the lid here, we put in the quick start guide. So that gives you an overview of how to set everything up. So if you're unfamiliar with operation or you pass it to somebody who's unfamiliar with it, they have the quick start guide here to get them up and running. The unit comes with your drive line and sample line adapters. So again, quick connects on either end to mate everything up quickly. Now moving on to the next piece, we have our portable compressor. So as I mentioned earlier, a pneumatic pump does require a gas source. So we do offer our low flow portable compressor, so good for depths up to about 100 feet or 30 meters. And that comes down to the overall tank volume on the compressor. So if you are going deeper than that, a larger 2-stage or a compressed cylinder would be what you would use. But for any of your low flow, shallower applications, this is a great option. So it runs off of 12-volt battery. So we have alligator clips here. So if you have a vehicle on site or a 12-volt battery, you can just clip those on. It has auto on off. So when you get everything set up, you turn that on and you start sampling. It will come on when it needs to, shuts off when it doesn't need to inflate or fill the tank up anymore. So you kind of set it and forget it. So it's a great option for portable setups, and you can see here I can lift it easily so one person can handle it in the field without any problems. And the last piece to a portable setup is our portable tubing reel. So hopefully a lot of you are familiar with our water level meters, and you're seeing a lot of similarities here. So we've got our nice convenient carry handle, sturdy frame, so when I set that on the ground, the tubing's staying up off the ground, so I'm not picking up any debris that I don't want to introduce into the well. We have our handle here, so with the portable setup, like I mentioned, you'd show up to the well, lower your pump into place, lock it with the lock here, do your sampling, unlock it, reel it back up. So really easy to lower the pump and raise it. We have our quick connect fittings on the front. So we have our quick connect for our drive line here. So from the control unit, that snaps into place easily with no tools. And on the other end, we have our sample line connection here. So you take a piece of tubing, run that to your sample bottle like you can see on the screen, and the sample would come up through the tubing out here to your sample body. Now in terms of tubing, what we usually do with a portable reel is we have our dual bonded, so it's dual strip tubing and it's bonded together. So that makes it easy to coil it on, and it keeps all of the tubing, organized. I have a short section here, so it looks like one, but it actually is 2 pieces of tubing. So you have one for drive line, one for your sample line. That's all connected through the hub, and again comes out to these quick connect fittings. So lots of different options available in tubing, but with the portable reel, typically we would go with the quarter inch dual strip bonded. So the reel itself, we offer it in 3 different sizes. So depending on the deployment depth that you're sampling at, we've got different size reels to accommodate that tubing. And on the faceplate and backplate, steel, so very robust, keeps everything protected. So all of those pieces together, one person can easily handle all of that to bring everything out into the field. And then obviously the sample bottle, depending on the type of sampling you're doing, there will be different sizes, different types to use. Now on the other side, looking at a dedicated setup, all of the pieces would be the same except for how you actually connect at the surface. So you would have, instead of the portable reel, we'd be using our dedicated well cap. So again, maybe some of you out there are familiar with our 2-inch locking well cap. From the outside it looks the same, but on the inside we have some differences. So our insert here, again, we have our quick connect, so we can connect our drive line quickly. On the other end, see it with the light here, we have push fits for our tubing, which would be running down to the dedicated pump. So that pump would stay in the well all the time, the tubing would stay, and it would be connected to both sides of our push fits here. And on the other end, I mentioned the quick connect, and we have a push fit for our sample line. So we'd come, have our sample line go into the sample bottle, put everything together, start sampling. When we leave, this would stay at the well as all the tubing running down hole to the pump. So everything from the well cap down would stay, and everything else you would take with you from location to location. Now we also have on the bottom our eye bolt, so that serves a couple purposes. One, we have a safety line. When we have a pump down well, we can tie off a safety line so we know that that intake depth is the same all the time. Plus, it supports the weight of the pump. And let's say you want to also deploy some of our level loggers, or you have some other transducers that you want to deploy. You can use that as a hanging point. So maybe you have some Kevlar cord or something like that. You can hang other pieces of equipment from that eye bolt. On the top here, we have an access hole, so that pops out. And see here, you've got an opening. So you're able to access the well without disrupting the pump down hole. So you take the cover out, and you can take static water level readings. So any of our water level meters, the probes will fit through there. So you're able to take that static reading without disrupting the pump or the intake depth down hole. So all in all, it's a great piece when you have a dedicated setup. Now, as I mentioned, that's the only difference. Everything else would be the same. So you still have your sampler, control unit, air source, and your sample bottles. Okay, so now you see all of the options we have available in terms of bladder pumps, double valve pumps, deployment options. That's great, but how do we actually now take all that knowledge and apply it to the applications that we come across daily or quarterly, whatever intervals you have? So like I mentioned at the beginning, I put together a few case studies. So I want to go through the background information on each, and from that, give a recommendation of the type of pump that I would use, and also explain why I came to that conclusion. So case study 1, what do I know? So I've been asked to do VOC sampling. I have 6 wells to sample yearly. My well is 2-inch in diameter. I have a depth to pump of 50 feet and a static level of 40 feet. So all of that together, I calculate that out, and I would say a 407 bladder pump portable setup. Now, how did I actually come to that conclusion? Well, the first one is VOC. So I know I need to have low flow, nice steady flow, and with VOC, I want to ensure that the drive gas hasn't come into contact with the sample. So I want to have defensible data when I submit that for analysis. So that puts me into the bladder pump, because I mentioned the drive gas only stays on the outside of the bladder and never comes into contact with the sample. So that right there puts me into bladder pump. Now a 2-inch well, I don't have any restrictions in terms of diameter, so I can use either the 1.66 or the 1-inch. For this, I probably would use the 1-inch just because it is a portable setup, so I have lighter weight, so when I'm lowering that and raising it, I'm using a lighter weight pump. Again, you can still use the 1.66 to have that increased volume if you want, but I'm looking at low flow, so I don't need to have that increased volume to have a higher flow rate at the surface. So the 1-inch is a great option. Another reason why I'm thinking bladder pump is I know at my depth, the pump is 50 feet, my static's 40, I have 10 feet of head. So I don't have a lot of water above the pump itself. So a bladder pump is a little more suited for a shallower head above the pump. So that's another reason why I'm looking at a bladder pump. Now, case study 2, again, what do I know about the well? So I've just been asked to do standard sampling, so just general water chemistry. So higher flow rates are possible, so no limitations there. 3 wells to sample every year. This time I have a 1-inch well, so a narrower diameter well, depth to pump of 30 feet, and a static of 15. So all of that together puts me into the 408 double valve pump, and I'll be looking at a portable setup. Now, why did I come to that conclusion? The biggest thing here is the the diameter of the well. So I have a 1-inch well, and I know with the pump options I have available, I can use my double valve pump 5/8 inch diameter. Now I didn't mention it earlier, but we do have a double valve micro pump, so a 408M, and that has a 3/8 inch diameter. So it's a specialty pump that we usually use with our CMT wells, but in this particular case with the 1-inch well, that would be a suitable option as well. Also with the double valve pump, you can get higher flow rates at depths. So with the standard sampling, I can do higher flow rates, so the double valve pump works out great for there. And portable, because I only have to go out and sample yearly, I don't really have the need, or I'm not really justifying spending the extra money dedicating pumps when I'm only going out once a year. Whereas with the portable setup, I can go with just one setup and sample the 3 wells, decon between sites, and I get exactly what I need to do. Case study 3, a little bit different story here. So the same, I'm looking at general water chemistry, so higher flow rates are possible. 5 wells to sample quarterly, so it's a higher frequency of site visits. I have a 4-inch well, and I've got a much deeper deployment. So I've got a depth to pump of 650 feet, and static is 300 feet. So all of that together makes me point to a double valve pump, and I'd be looking at a dedicated setup in this particular case study. Now, why am I coming to that, or why did I come to that conclusion? First thing is the depth. So I'm looking at 650 feet. So again, I mentioned a double valve pump, you can obtain higher flow rates at greater depths. And in this particular case, I've been asked to do 3 well volumes, or I'm doing 3 well volumes. So I want to get as much of the sample to the surface as quickly as possible. The 408, I can do that. Now I've got a 4-inch well, so I can use the 1.66. I've got a larger diameter body, so I've got increased volume within the pump, so I can get more of that sample up. And I'm looking at a dedicated setup because I have to go out and do quarterly sampling. So one, I'm doing a lot of site visits, so you'd be spending a lot of time bringing the pieces out, packing it up, bringing it back. So it would be easy just to bring my gas source and my control unit, connect, and I'm good to go. And the second part to why I'd want to use a portable setup, just with the overall depth. So 650 feet, that's a lot of tubing, and it takes a lot of time to lower and raise the pump up. Plus then I would need to decon 650 feet of tubing between each of the 5 wells. So this one works out great for a dedicated setup. I lower the pump down, I've dedicated tubing, so I'm not spending the time each time I go out quarterly to lower, raise, decon. So perfect application for a dedicated setup. Now I mentioned earlier in the presentation with the portable reel, we would usually use the 1/4-inch by 1/4-inch bonded tubing. In this particular case, I'd be looking at single line tubing, and I would be looking at 3/8 inch for the drive line and 1/4 inch for the sample line. Now, why do I want to have a larger diameter drive line? Well, if you think back to when I was talking about the differences between the 2 pumps, with the double valve pump, when I lower that down into the well, water fills up through the pump body, but it also goes up through the drive line and the sample line to the static water level. So now I have in the drive line, which is then getting pushed down when I drive the gas from the surface down into the pump body, I'm pushing a larger volume of sample down and then up through to the surface. So that's how you can get a higher flow rate as well. By all means, I could use the 1/4 inch, but if you can envision 650 feet of tubing with 350 feet actually having water in it, the difference in volume between a 1/4 inch and 3/8 of an inch, that's substantial. So it's just going to give me an overall quicker result up at the surface, so I can move on to the next well quicker between sampling events.